Hello to all. In this video, we are going to discuss about Synopsys Sentaurus TCAD and various tools that are being used in the Synopsys Sentaurus TCAD. So, in the next slide, we will discuss about the outlining of this video. So we will discuss what is TCAD software, Synopsys Sentaurus TCAD, overview of Synopsys Sentaurus TCAD, various Sentaurus TCAD tools, Sentaurus TCAD workflow, device simulation steps, TCAD and semiconductor industry. Then the last one is process simulation and device simulation. So, what is TCAD software? Full form of TCAD is Technology Computer Aided Design, which helps to design the various electronic devices like BJTs, FETs, HEMTs, organic devices, photonic devices, sensors, and circuit designing as well. It is included the fabrication steps, device optimization and circuit simulation as well. So we can see in this diagram as well that in this with the use of this TCAD software, we can design the device, its fabrication and the circuit as well. Now I'm going to discuss what is Synopsys Sentaurus TCAD. It is basically a bundle of various tools which develop and optimize semiconductor process technology and devices. It provides the powerful platform for GUI-driven environment for managing the simulators, tasks and analyzing simulation results. Sentaurus TCAD is also used in the industry due to its ease in the simulation environment of the devices and reduced cost. It also integrates the various environment in one single environment. It delivers the production proven modeling solution for logic memories, power and CIS applications. It also offers smart technology modeling which reduce the cost and the time, which leads to the boost in the research organization. So, in this slide, we will discuss the overview of Synopsys Sentaurus TCAD. In the overview of Synopsys Sentaurus TCAD, we will discuss about the various tools which comes under the umbrella of Synopsys. Basically, Synopsys is the company that holds all the tools related to its devices, interconnects, and even atomic scale devices. So, first of all, this picture has all the tools that are under the umbrella of Synopsys Sentaurus, not on Synopsys Sentaurus, Synopsys. So, first one is atomic scale modeling. In the atomic scale modeling, quantum ATK tool simulates the properties and transport mechanism of novel materials and device structures, enabling the down selection of promising material for further exploration. In this atomic scale modeling or using the quantum ATK nanolab, you can create new materials, you can create new properties of those materials, and using those properties of materials you can create the new devices. So next one is process simulation. The next tool is basically process simulation. Centaurus process is the industry standard for simulating the fabrication steps of semiconductor process. In this, it deals with silicon-based logic memory, power, CIS technologies to silicon-based technology. Basically, process simulation deals with the fabrication of each device. In the fabrication processes, Sentaurus process, or you can say Sprocess tool is used. Next one is Sentaurus topography, which used for 3D graphical user interface for the process simulation. In the Sentaurus process, which supports the modeling of implantation, diffusion and dopant activation, thermal oxidation, mechanical stress and epitaxial growth. So we can see that all the fabrication steps can be covered in the Sprocess simulation. Sentaurus topography supports the modeling of topographical steps including etching, deposition, CMD and electroplating. So in conclusion, we can say process simulation is the tool in which we can easily fabricate the device in the virtual manner. So the next tool is process emulation. In this tool, we use this tool for fast 3D process emulator used to identify and correct the process integration issues during the technology development. It also linked to the Synopsys Sentaurus TCAD simulators like RefLFX, which enable the high accuracy RC extraction in design technology and co-optimization. Now, process emulation basically creates the device and evaluate the device on the basis of various parameters. In the process simulation, we can also get the results in which we can easily identify the issues during the fabrication process. So the next tool is Sentaurus structure editor. Basically, structure editing is done with the Sentaurus structure editor, which is used to create structure for device simulation when process simulation is not required. So sometimes we do not require process simulation, we just require the geometric structure of the device. So with that, we can easily create the structure using structure editor. It provides the geometrical structure of the device with the help of GUI interface, in which enable the engines available in the Sprocess and Sdevice. Basically, SDE, the structure editor, only provides the geometrical interface. It does not have the simulator. It is not the simulator basically. So we can include this structure in the simulator device and then we can easily get the results. So next is device simulator, in which the device simulation is done with the help of Sdevice simulator, which studies the electrical characteristics of the silicon based and compound semiconductor devices, such as response to external electrical, thermal and optical boundary conditions. Now, Sentaurus device is a simulator which simulate all kind of devices, which basically enables the user to define the devices with their own ideas and simulate it with the physical models which are already present in the Sentaurus devices. In the device simulation, advanced physical model for quantum effects, ballistics transport, tunneling process, stress, hot carrier injection and other transport mechanism will be optimized. So we can see that Sentaurus device is the main simulator that holds all kind of electrical behavior for a device. So next one is interconnect simulation, which is done with the help of Sentaurus interconnect. which studies the electrical properties of interconnect. So the next tool is the environment, which is basically the Sentaurus Work Bench. Now, the Sentaurus Work Bench is a complete graphical environment for creating, managing, executing and analyzing the TCAD simulation. It is a bundle of all the environment in one go. It navigates and automates the typical tasks associated with running TCAD simulations, such as managing the information flow, including the pre-processing of user input files, optimization and at last visualization of results. The next tool is Sentaurus Visual. In the Sentaurus Visual, we can easily visualize the results of the Sentaurus device. We can just select the file from the Sentaurus device and we can easily visualize the various electrical properties like electric field, potential, mobility, all can visualize in the Sentaurus Visual. So this is basically the environment of the Sentaurus TCAD. Now till here we create the device. Now we can easily create that device and convert that device to the circuit. So TCAD to SPICE, we can easily standardize the SPICE model parameters extracted from the TCAD outputs with the help of M.tech software, which enables the knowledge and development of DTCO, which is the application of new transistor design. Various Sentaurus TCAD manuals can be accessed through this page, in which you can see all the tools are defined and you can click on any tool, you can direct it to its manual, because to study or to create any device we need manuals. So all the manuals are presented here. Various Sentaurus TCAD tools will be discussed in this slide. Now we have already know about Workbench, Sentaurus Process, which is used for the fabrication, Sentaurus Topography, which is used for the issues and integration of fabrication with the device, Sentaurus Structure Editor, which creates the device geometry, Sentaurus Mesh. Now Sentaurus Mesh basically mesh the structure editor geometry which creates the boundary conditions with the finite element structure. Next, after that device simulate with the help of Sentaurus device. We usually called Sentaurus device is S-device. Now next is Sentaurus device electromagnetic wave solver, which is used for the electromagnetic field and electromagnetic devices. Sentaurus interconnect used for the interconnects, and Sentaurus Visual is used for the various results that you can get from all above tools. Sentaurus Data Explorer, Inspect, and the last one is Calibration Kit, gives you the different types of visualized results which can be discussed, and further you can analyze those results. Now in the next slide we will discuss about the workflow to create the device. The device can be created using process simulation and then we can go for the process emulation. After that, we design the device and simulate it with the S-device. So this is all the steps of device designing. The device designing also include the step of device geometry, including the various models, applying the various boundary conditions, and then visualizing those results in the S-visual. S-visual is basically a Sentaurus visual device. After this procedure, when you get the result of design device in the S-visual, you can model that device for the SPICE-like modeling. Like, you can easily get that device from the TCAD output and model that device in the SPICE models, which are standard models, to convert those devices into the circuit simulation. So in the SPICE-like modeling, you convert the compact model of the TCAD device into the circuit design. So easily we can create the circuit. Now, device simulation steps. Getting the device geometry and doping concentration from the process emulation is the first step. It is also the pre-processing step. After that, we need to mesh the device for the numerical computation, because we have to provide the various boundary conditions and we have to calculate the electrical current or electrical behavior of the device at each and every node of the device. So for that, we need to mesh the device. After that, we have to solve the Poisson equation, current continuity and transport equation on the defined mesh for some given boundary conditions. This is basically called processing, and these all are occur in the S-device file. Basically, we have to create a file for S-device which includes all the boundary conditions, all the equations, all the physical models and all the meshing files. So we can see the physics description is in the S-device file. Now, when you simulate this device file, after that simulation, you can easily visualize the results for the electrical results and internal quantities like electric mobility, stress, current and your electric field, also the potential as well. Now, how the TCAD is dealing with the semiconductor industry. In the semiconductor industry, TCAD is vastly used with the two major steps, process simulation and device simulation. I think we have already know that what is process simulation and what is device simulation. So let's give a brief introduction. In the process simulation, processing steps such as etching, deposition, ion implantation, thermal annealing and oxidation are simulated based on the physical equations, which gives you the results for that, and you can easily extract those results to create another device. In the device simulation can be thought of as virtual measurement of electrical behavior of that semiconductor device, such as a transistor or a diode. The device represents a meshed finite element structure. Each node of the device has properties associated with it. Basically, in the TCAD, Sentaurus TCAD, it has trapezoidal mesh. So it is very easy to calculate the device and accurately calculate the device, all the parameters. For example, the carrier concentration, current densities, electric field, the generation and the recombination rate, and so on. Electrodes are represented as the area on which boundary conditions are applied. Basically, we call the boundary conditions which are the voltage applied to the electrodes. So device simulator solve the Poisson equation and their continuity equation with these boundary conditions. So we can see that with the help of device simulator Sdevice, and we can with the help of Sdevice simulator, current flows in the direction we can see easily in the diagram. So the lines that are visible to you are showing that current conduction from the source to the drain region. So in the S visual we can get this result, which are for the various VGS. This is the result for the drain voltage versus drain current at the various VGS. So this is all about the brief introduction of Sentaurus TCAD. In the next video, we will one by one discuss about the various tools that we have today introduced in this video. So get tuned for the same. Thank you. Have a nice day.